Welcome to lecture 28 of the course CS213 Object-Oriented Programming of the Kohat University of Science and Technology. In this lecture we will look at generic collections, what generic collections are and how they can be used, and we will be using collections in our future lectures, so we'll try to understand the concept of different types of collections that can be used in Java before we go to their applications. Collections, as opposed to arrays, are used to hold groups of specific types of items, as arrays is a kind of a collection that can be used to hold groups of specific types of items. Collections are containers designed to hold generic or any type of objects. In Java, collections let you store, organize, and access objects in an efficient manner. The different collection types are vector, stack, dictionary, hash table, properties, and enumeration. Although we won't be looking at all of them over here, but we'll be looking at some of them in a little bit of more detail based on our applications of these collections in our future lectures. Vector, for example, the vector class implements a growable array of objects. Like an array, it contains components that can be accessed using an integer index. However, the size of a vector can grow or shrink as needed to accommodate adding and removing items after the vector has been created. Unlike the array, we can add or remove items into our vector. In Java, this is supported by vector class contained in java.util package. The vector class can be used to create generic dynamic arrays that hold objects of any type or any number. And this is where it is different from arrays, where in arrays we can only store a specific type of an object with a specific number of elements in that array. The objects do not have to be homogeneous. It means that we can store different types of objects in a vector. Like arrays, vectors are created as follows. Vector is the name of the declaration, list is the name of the vector, and we have declared our vector list without size. Vector list with a size, that is the initial size of the vector is 3. The properties of the vector possess a number of advantages over arrays. It is convenient to use vectors to store objects. A vector can be used to store a list of objects that may vary in size. We can add and delete objects from the list as and when required, but vectors cannot be used to store basic data types. For example, we cannot store basic data types like integer, floats, etc. We can only store objects in vectors. To store basic data type items, we need to convert them to objects using wrapper classes, and we will discuss these later in our lecture. Important methods in vector class include adding an element. For example, the add element method we will pass the item that we want to add to the vector as an argument. We can insert an element at a certain position by passing the item that will be an object and the index position where we want to insert the item at. Element at an index, get element at a certain position, remove element at a certain position, that we will use the remove element at method. For that, we can get the size of the vector using the size method. We can use the clone method to return a clone of this vector. We can use the clear method that will remove all of the elements from this vector. We can use the get method that returns the element at a specified position in this vector that will be passed on as an argument to the get method. we can use the copy into method that will copy all items from vector to an array. The array will be passed on as an argument. This is an example of using the vector, where we can see we have class vector1 and we have declared a vector, and we want to know the length of the vector. So we have added certain elements to a certain circle as the radius of the circle. So we have 5 radius circles of different radii, and we want to know the size of the vector. This is what we are interested in. The initial size of the vector is 0, as we have declared the vector without any size, and then we have added 5 elements to our vector using this for loop, and then when we measure the size or declare the size of the array, return the size of the vector, that will be 5. In another example, let's say we want to insert an element at a certain position with a certain value. So this is where we insert an element into our vector, and now if we return the size of our vector, it will return 6. And if we go through our vector, we can print the elements of our vector or here. The hash table or hash table class should be a class, allows associating values with keys, allows efficient lookups for the value associated with the key. This class implements a hash table which maps keys to values. Hash tables use key value pairs, and this can be quite useful. Any non-null object can be used as a key or as a value. Useful operations include put, where we can add a key value pair into the hash table. We have an object, a key object, and we have a value object. We can use the remove method to remove a certain element from the hash table. We only need to pass the key of that element, and we can use the get method to get a certain value using the key of that value. Hash table put get operations. The following example creates a hash table of numbers. It uses the names of the numbers as keys. So this is how we can create a hash table, and then we can add data to that hash table. As I said that we hash table use data in the form of key value pairs. So this can be the key, and this will be the value of that key, and then we have can add as many numbers or as much data or elements to our hash table as we need. To retrieve a number, use the following code. Integer n is equal to, and this is the wrapper where we can get the value at this position into an integer variable, and we need to pass the key of that element. So it will return 2 and store that 2 in this variable n. So if n is a non-null value, then that value will be printed. And this is an example that demonstrates the use of hash table. We will be using hash tables in our future examples as well. But basically we are declaring a hash table, and we have two objects of the student class that we might have declared somewhere else, and we have the key value pair for this student. So we'll get an ID for the user and put that as key for the student in the hash table, and then we will put the details of the student. As we can see, we have put the object of the student over here as the value for the student, and we do the same for another student as well. We get the ID and we store the object along with the ID of the student over here. As you can see, we have used composition over here, where we are using the complete object as a value in our hash table. and we can then return the details, all of the details of a particular student into this object, and we can display those details over here. Enumeration is used to enumerate or iterate through a set of values in a collection. Useful for iterating hash tables. It has no index. Useful operations include if we want to check if a hash table has more elements, if there is a next element. This is a demonstration of the enumeration. So we have a hash table object and the student class with the student objects, and then we have put some data into our hash table as we did previously. But if we want to go through the hash table, so we declare an enumeration of all the elements of the hash table, and we keep going as long as there are elements in this enumeration object. We can print all the details of all the students with the help of this enumeration object. So it will check if it has more elements, then it will convert each element to the student object and print those details or the names of the students over here. So this is how we can use enumeration over here as well. Wrapper classes, although we will discuss these wrapper classes in detail in the next part of this lecture. As pointed out earlier, collections cannot handle basic data types such as integer, float. They can be converted into object types by using the wrapper classes supported by java.lang package. So for the basic type boolean, we have a wrapper class boolean with a capital B. For the char class, we have a character class. For the int data type, we have the integer class. For the long data type, we have the long class. For the float data type, we have the float class. And for the double data type, we have the double class. The methods in the wrapper classes, for example, there are constructor, where we can return the value of an integer. For the integer data type, we can return the value of float. For the float data type, using the float class, wrapper class, we can convert the objects to their basic values. So if you want to get the integer value of this object, we convert it into the basic data type. If we want to convert this float object into a float data type, we can use this expression to convert it into a float data type. Similarly, we can convert numbers to strings. So if you want to convert this string to this integer to a string, you can use the wrapper classes and use the toString method. Similarly, we can do is for the float. And the string objects to numeric objects, as we said that we can use the value of method to convert the string objects to numeric objects, as we can see over here, the float object to the float for the float, and we can also convert the numeric strings to basic types as well. So if we have a string that is a number, that contains a number, then we can convert that into an integer using the parseInt method. Similarly, we can use the parseFloat method. These methods throw exception number from format exception if the value of the string does not represent an integer. Exceptions are object-oriented way of reporting errors. We have discussed these problems in our exception handling lecture. You can go through the lectures and we discuss exactly this number format exception over there as well. So to summarize, a special method toString can be defined in any Java class which gets invoked when one tries to concatenate operation with strings, as we saw in our previous example. Collections are like arrays but can hold any objects, dynamically expandable, and supports their easy manipulation. Java has a strong support for collections, which are very useful when developing large-scale software development. Wrapper classes helps in manipulating basic data types as objects. This will conclude this part of our lecture of collections. We will continue our discussion of collections. In the next part, we will discuss the array list.